Okay, variance, standard deviation, and the normal curve, all this crazy statistics stuff. All of this stuff is about the spread of your data, and it's just a standard deviation is just another way of examining your spread of data. And then it has a pretty specific meaning where we're going to use it on a bell curve. So before we get into all of that, let's just talk about the formulas again and how to find it. So variance, all the variances is what you get before you find the square root of the standard deviation. The value of the variance we don't really ever use, but it's good to have that formula. And then the standard deviation, if you notice, this part is the exact same formula as this, except you find the square root of it. So basically, let's just take the formula. The xi is your data point. So you take every data point. So here, right here, we would take all of our 5 data points. We would subtract this mu here. That stands for the mean. Then we square it. So we do that to every data point. And remember, this right here means find the sum of all of them. So you average them all together. You divide by how many numbers you have. And then you find the square root of the whole thing. And the reason we find the square root is because we've just squared all of the numbers. Just like the mean absolute deviation, we were finding the absolute value to avoid having a negative. This is a different statistic where we're squaring all of the data, and the reason we're squaring all the data is because we want to deal with positive numbers, and then the reason we find the square root of it is because we're taking away the fact that we squared it, so then we get another number that tells us. So your standard deviation and your MAD, oftentimes they won't be the same number, but they'll be pretty close to each other. So let's go ahead and take Joe and Sue's scores again. These are the same scores we did for the MAD. And the very first thing you're going to do is find the mean. We've already found the mean. We found it the other day. The mean is 75. Remember, both datas were 75. So let's go ahead and do Joe's standard deviation together. So x1 basically is just like the first data point. So I'm going to put 45, and the next one, 53, 85, 96, and 96. Do you guys hear that rain? It's crazy raining right now. All right, so now the deviation from the mean is just the difference, just like we did with the MAD. We're going to do 45 minus 75, and that gives us negative 30. Then we're going to do 53 minus 75, that's negative 22. Then 85 minus 75 gives us 10. 96 minus 75 gives us 21, and we do that twice. And then the next thing we're going to do is we're going to square the difference, just like what the formula says. We square the difference. So negative 30 is 900. Remember, when you square a negative, you always get a positive. So negative times a positive is a negative times negative is positive. And then negative 22 squared is 484. 10 squared is 100. 21 squared is 441, and we have that twice. So then we're basically going to find the average of the last column. We're going to add those up, and we're going to divide by how many numbers we have. So if you add those numbers up, 900, 484, 100, 441, and 441, that's going to give you 2,366. And then we're going to divide that number by 5. That's the average of our squares. That's going to give us 473.2. Now that number right there, that is called our variance. We're not interested in our variance, we're interested in the standard deviation. So then our very last step is we take the square root of 473.2, and I'm going to round that number to the nearest tenths place, which is going to give us 21.8. So now what I want you to do is I want you to stop the video and try the next column on your own and then tune back in. Alright, I went ahead and filled out the chart for you because I think you can do that on your own. And the average column you're going to find, you're going to do that, that's going to give you 42 divided by 5. This is just adding up these numbers. We're adding up those numbers, we're finding the average, and that gives us 8.4. That, again, is called our variance, and then then find the square root, and you get 2.9. And 2.9 is your standard deviation. All right, so now on the next page, what I want you to do is try to work through those problems on your own, and then come back, tune back in, and I'll work through them with you. Okay, let's see how you did. So the first step we need to do is we need to find the mean. And I should point out that what we're doing is we're talking about the high temperatures in Charlottesville last week, and then number 2 is going to be the high temperatures in Miami last week. So before we even start, let's think about who's going to have a higher mean absolute deviation and who's going to have a lower mean absolute deviation. Same with standard deviation. Keep in mind, standard deviation and MAD the numbers are going to be close to each other. Not the same number, but they're going to be close to each other because they are talking about the spread of the data. So before you even start, take a look at your data and just think, who is going to have a bigger number? And let's go ahead and figure it out. So the mean for the first set of data would be 68. I got 68 here. So you add them all together, you divide by 7, and you get 68. All right, so the MAD. Remember, to get the MAD, you subtract 64 minus 68, find the absolute value. So all of those numbers are going to be positive. So 64 minus 68 is 4, negative 4, but the absolute value of negative 4 is 4. And then the next one, 78 minus 68 is 10. And 58 minus 68 is negative 10, but the absolute value is positive 10. 81 minus 68 is 13. 64 minus 68, again, absolute value gives us 4. 61 minus 68 gives us 7, absolute value of that, of course, and then 70 minus 68 is 2. So all of those numbers, those are all our top numbers. We're going to divide all of those numbers by however many numbers we have, which is 7. When you add up the whole top, you get 50, and you divide 50 by 7. We're going to round that number to the hundredths place to 7.14, and that is our MAD, our mean absolute deviation. So again, explain what the MAD value means. Well, high temperatures in Charlotte last week were these numbers, and the MAD is 7.14. So it's going to be degrees. Basically what this means is that the high temps last week in Charlottesville were on average 7.14 degrees. So we're on average 7.14 degrees from the mean of 68 degrees. So I'm just going to say from 68 degrees. So the spread, like that's the average distance all of the temperatures are from the mean of 68 degrees. Okay, standard deviation. So if you notice, the first step in mean absolute deviation is the first step in standard deviation. You take the mean and you subtract. You basically take each data point and you subtract each data point and you subtract the mean. And if you notice, we already did that here. The only difference now is we're going to square them. Yeah, so some of these numbers would have been negative, but it's okay because when you square a negative number, you're going to get a positive number. So basically, if you've already found the MAD, all you have to do is take all of the numbers here at the top and square them, because this is the x minus mu already. So 4 squared is 16. 10 squared is 100, and we have 2 of those. 13 squared is 169. 4 squared, 16. 7 squared, 49. And 2 squared is 4. So take all of those numbers. We're going to divide that by 7. And don't forget, if I just stop there, that's the variance. I want the standard deviation. So then I'm going to find the square root of everything at the very end. It's a really good idea to draw that square root symbol. Alright, so I add up all the whole top, and the whole top gives me 454 over 7, and then I'm going to find the square root. Now we're going to estimate. So what I'm going to do is I'm going to divide 454 divided by 7 first, and that I'm going to just round to the hundredths place again. I'm going to get 64.86. If you've already done it and you rounded to a different number, that's fine. So 64.86 is what you get when you divide 454 divided by 7. Then we're going to find the square root of that number, and I got 8.05 rounded to the hundredths place. And that is your standard deviation. What I want you to do now is stop the slide and now look and see what you get for number 2 on your own. Okay, for letter A, you should have gotten 79. For the MAD, you should have gotten 2.57. And for what the MAD value means, I just wrote, it's the same thing that we wrote here, except that the high temperatures last week in Miami were 2.57 degrees from the average of 79 degrees. And so then the standard deviation, you should have gotten 3.07. So if you got some of these wrong, maybe pause the video and take a look at my work and see if you can figure out what you did wrong. And if you got them right, basically, let's just talk about this for a second. if you notice at the very beginning I asked which one's going to have higher. Well, if you look, the spread of this data, these numbers are a little bit further away. Like these numbers are bigger. These numbers are all pretty close to the average of 79. And if you think about temperatures in Miami are going to be a lot close. Like they're pretty steady. Temperatures in Charlottesville, we live here. How often do we wake up and we're freezing cold and we put on a sweater and then we leave school, it's like 75 degrees outside, right? So, and then the next day it's like 68 degrees, and then the next day it could be like 50. So temperatures fluctuate, especially this time of year. Temperatures fluctuate a little bit more in Charlottesville, which is why our MAD and our standard deviations are going to be a little bit bigger. All right, on the next page of this is explanations of standard deviation and where we put them. So go ahead, flip to the next page of your sheet and read it. So, in order to understand standard deviation, you have to kind of understand this higher level math concept called the bell curve. And the bell curve, you're going to learn a little bit more about it when you get into high school, and if you take statistics in college, you're going to learn more about it in college. But the bell curve has everything to do with normal distribution. So if you read what it says about normal distribution, basically normal distribution, things like your height, everybody's height is basically normally distributed. People's weight, their blood pressure, job satisfaction, reading ability, IQ, all of these things are normally distributed. Like most people fall really close to the mean or the median of this data. So if you were to take, basically if you take a look at that very first graph, this graph right here, if you were to take, I don't know, millions of people's IQ scores and you were to make a histogram out of it, most likely you would end up with most people falling within 85 and 115, the mean being in the middle. So most people are going to fall within these two bins right here. And there's fewer people that fall above the mean and fewer people that fall below the mean. And so if you look at this histogram kind of makes what we call the bell curve. And so over here is me just showing you, oh, there's the bell, okay? And so then here's what the bell curve looks like without the histogram, like the tops of the histogram in there. So basically, to be normally distributed, most people will fall within these two bins. And so if you pay attention to the bell curve, if you look at it, it's completely symmetrical. 50% of the distribution falls on this half and 50% falls on this half. So the bell curve is covering 100% of the information. We're going to be talking about percentages of the area under the curve. And there's so many things you could do with the bell curve, but we're only really going to talk about the 68, 95, 99.7% rule. So if you look at this curve, and the fourth picture on your paper shows this, but this whole curve represents 100% of the data, and about 68% of the data will fall right here. So this is about 68% of the data. And I'm rounding to just 68. Your paper says 68.26. We're just going to say a flat out 68% of the data falls there. We say that this 68% of the data falls within one standard deviation above and below the mean. And so the mean is always the number in the middle. And in a normal distribution, the mean and the median are always the same. So then if we take this out even further, we say that from here, 2 standard deviations from above or below the mean covers 95% of the population. So we're going to say that this holds about 95% of the population. So then you take it out. The third standard deviation, which I'm a little running out of room here, the third standard deviation covers 99.7% of the population, falls within 3 standard deviations from the mean. So now let's go ahead and take a look at this chart. So if we're looking at this bell curve, based on the graph of the IQ scores. So if you look down here, the IQ scores are written right here, and above it is how many standard deviations above or below the mean is. The mean IQ score is the thing right in the middle, and it's 0 standard deviations from the mean because it is the mean. So the mean score is 100. Now, the standard deviation is the range between each bin. So if you look, what we're counting by here, if you look, we're going from 100 to 115 to 130 to 145. And if we go backwards, we're going back to 85, back to 70, back to 55. The distance between those numbers is our standard deviation. So that is 15. So when we were calculating the temperatures and we got the 3.05 or something for Miami's, that would be, we would put the mean in the middle, and then all of the numbers above and below are all the standard deviation. We would count up by the standard deviation or back by the standard deviation. So then letter C, about 68% of the data have IQ scores between what and what? Well, your picture looks a little different than mine, but I showed you from here to here is 68% of the data. These two bins right here cover 68% of the data. So if you look, that's between 85 and 115. And this is said to be 1 standard deviation from the mean. So above and below, we just say 1 standard deviation from the mean. About 95% of the population falls between these two standard deviations above and below the mean. So 95% would be between 70 and 130. So 70 and 130. This is 2 standard deviations from the mean. This is just how we talk about these things, basically. So 99.7% of the population have an IQ score between 55 and 45, because that now takes us out to here, 55 and 45. And this, 145. And this is 3 standard deviations from the mean. All right, so now Amanda's IQ score is 130. This is better than what percent of the population? So this one's a little bit tricky. So she's right here, okay? She is at 2 standard deviations above the mean. So now we need to think about this entire curve. This entire curve is 100% of the data, all right? We know, I'm going to go ahead and erase parts of this. We know that 2 standard deviations above and below the mean is what percent of the data? 95% of the data. So we're going to say, so from here to here is 95% of the data. So we're not going to say she's better than 95% of the data because we need to account for these numbers right here. So what we're going to do is we're going to say, okay, so the distance from here to here is 95. The entire curve is 100% of the data. So if you think about it, we have, if this whole thing represents 100% of the data, and between 2 and above and below 2 standard deviations from the mean is 95% of the data, we have 5% of the data not accounted for. And keep in mind, since this is symmetrical, half of that 5% is going to go on this side, and the other half is going to go on that side. So this shaded in region that I have here, that's 2.5%. And this non-shaded region over here is 2.5% as well. So she is better than 97.5% of the population. So let's do some basic questions. Like number 1, a normal distribution with a mean of 7 and a standard deviation of 2. And I want you to display this information on the graph. Well, the mean goes in the center. So we would put 7 there. And since it has a standard deviation of 2, I'm going to go up by 2, 9, 11, 13, and then I'm going to go down by 2. And that's going to be 5, 3, and 1. And then we get to answer a bunch of questions about that once I have it. Take a look at number 2. Very similar. A normal distribution with a mean of 500 and a standard deviation of 100. So 500 is going to go right in the middle, and I'm going to go up by 100 every time. So 600, 700, 800, and then I'm going to go back. 400, 300, 200. All right, Go ahead and fill out number 3 on your own, and then we'll answer the question together. So, for number 3, you should have put 800 right in the middle. So we've got 800, and you're going up by 65. So we've got 865, we've got 930, and 995. And then going backwards from the 800 is 735, 670, and 605. All right, so now, to answer the question, your cow weighed 930 pounds. How does your cow compare to the others? There are several different things you can say here. We're going to talk standard deviations from the mean, and we're going to talk percentages. So if you look, 930 is how many standard deviations from the mean. So remember, the mean is right here. That's 0 standard deviations from the mean. This is 1, and this is 2. So you're going to say, you could say that your cow is 2 standard deviations above the mean. If we want to talk percentages, just like the question we did before, we know from here to here is 68%, which means from here to here is 95% of the data. And then as we figured out before, if you cut 95, if you take 95% out and you've got 5% left, then 2.5% fits on this part of the curve and 2.5% fits on this part of the curve. So your cow is heavier than 97.5% of all other cows in this fair. Okay, so that's what you're going to say there. I didn't write the whole thing out, but you would say that your cow is 2 standard deviations above the mean, and compared to the rest of the cows, he's much heavier. He's 97.5% heavier than the rest of the cows. You could even say there are only 2.5% of cows that are heavier than your cow, so you got a pretty darn heavy cow. All right. Go ahead and try number 4 on your own. Go ahead and stop the video and see if you can do it. Alright, check to see if you filled out your chart correctly. The mean is 30 minutes, so that goes right in the middle. The standard deviation is 7, so we go up by 37 and then down, or not up by 7 and then down by 7. So then it says you study for 23 minutes a night. How does this compare to others? Well, if you look, you are 1 standard deviation below the mean. So you could say, I'm 1 standard deviation below the mean. The other thing you can think about is the percentage values that we've got here, right? So you know that from 1 standard deviation below and 1 standard deviation above, what percent is that? It is 68. Don't forget the 68, 95, 99.7% of the data. So now what I'm going to do is I need to think about, okay, this part of the curve right here, this is, you are better than this percent. You study more than this percent of the people, or less than all of the people above you, right? So to think about this, you know the whole curve is 100% of the data. So if you subtract 68 from 100, you get 32%. So you need to split that 32% to this half. So that is 16% on this half and 16% on that half. So you could say that you study only 16% more than most people, or if you're really thinking about it, if you do 68 plus 16, that's 84%. 84% of students study more than you. That would be how you would say that. All right, go ahead and try the next one. So, a lifetime of battery is normally distributed with a mean of 40 hours and standard deviation of 1.2 hours. You put a battery in your calculator, it lasted for 41.2 hours. How does this compare to others? So, the mean, again, is going to go right in the middle. I've run out of room here, so I'm just going to write one of them. So, that's 40, and then 41.2 is going to be 1 standard deviation above the mean. So, you have a battery, because it's above the mean, you have a battery that performs better than others. So to really talk about, well, how much better does it? Well, same thing. You know that the 1 standard deviation above the mean and below the mean, from here to here, that's 68%. And then just like number 4, we're going to take 68% from 100. We need to split 32 in half, which means I'm going to have 16% over here and 16% over here. So basically you're figuring out like a piece of your data and then splitting what's left out of 100 on each side, right? So you perform, your battery is this part of the curve right here, which is 68 plus 16. And 68 plus 16 gives you 84%. So again, your battery is 84% better than other batteries. All right, let's look at the next one. As always, I encourage you to do them. Stop the video and try it yourself before you go on. So the length of wear on star tires is normally distributed with a mean of 60,000 and a standard deviation of 5,000 miles. Shade the region under the curve that represents the tires that last between 50,000 and 70,000. What percent of tires does that represent? So we're going to have 60K right in the middle. So I'm going to put 60K for 60,000. We're going to have 60K, and we're going up 5,000. So it's going to go 65, 70, 75. You have to excuse my handwriting. It's not that easy to do this. And then we're going to go backwards. 55K, 50, and 45K. All right, so then we're going to shade the area from 50,000 to 60,000. So we're going to do this. Shade, 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 all the way to there. And luckily, this one is actually a pretty simple one because if you look, these from here to here, those equal distance right there, that's 2 standard deviations below and above the mean. That's a really simple one. That's 95% right there. All right, let's move on to the next one. So, the number of crackers in a box of Cracker Box crackers is normally distributed with a mean of 75 and a standard deviation of 2. So, I'm going to go ahead and put 75 in the middle. Excuse my cat and the dog are having major issues. We have a new dog in the house. So, yeah, the cat's not loving that dog. So, 75, 77. 79, and 81, and then we're going to go backwards, of course, so 73, 71, and 69, and it says shade under the curve, so from 73 to 77, so I'm going to go from here to here, and then it's like, what probability is this going to happen? Well, probability can be taken from a fraction, or from a percent, and so we know that's 1 standard deviation above and below the mean. That's 68% of the data, 68% there. So if I want a probability, I'm going to say that's 68 out of 100, because 68% is out of 100, and just simply divide by 4? Yeah, divide by 4. And that's going to give you 17 over 25. So the probability is 17 out of 25. All right, now number 8 is a little bit more involved than that. The length of time it takes to groom a dog at Shaggy's Pet Shop is normally distributed with a mean of 45 and a standard deviation of 10. So we're going to go up to 55, 65, 75, and backwards to 35, 25, and 15. Shade the region under the curve that represents the dog grooming between 35 and 65. So 35 and 65. Now, if you look at this, this one's a little bit trickier. So it's not, what it is it includes 1 standard deviation above and below the mean plus this little section right in here that I'm scribbling. So we need to actually do some subtraction and some division and all of that to really figure that out, right? So we know that from 1 standard deviation above and below the mean, this is 68%. Right? And then we know here, from here, all the way to here, well, that's 95%. So I don't want that piece, right? So I know this is 68%. What I need to do is add in this piece. Well, to figure out that piece, I need to figure out what each of these two things are, right? So if you do 95 minus 68, 95 minus 68 is going to give you 27. And so that means that these two pieces, the piece on this section and this second section, has to add to give you 27. So I'm going to divide that by 2. and that's going to give you 13.5. So then this piece, that piece is 13.5, and so is that piece is 13.5. So if I'm trying to get the fraction, I got to start with the percent, right? So from here to here, this area that I'm shading right here is 68, plus just this piece right here, that's 13.5. So 68 plus 13.5 gives me 81.5%. Well, 81.5%, well, that's out of 100, right? Now, we can't have, I'm going to go over here now, we can't have decimals inside fractions. So if you just multiply each of these by 10, or just slide the decimal point over one place, because that's what happens when you multiply by 10, you get the fraction 815 over 1,000. So now we need to reduce that fraction. So right off the bat, I know that I can divide both of these numbers by 5. If I divide 815 by 5, I get 163, and 1,000 by 5 is 200. And 163 over 200, 163 I don't believe can be divided anything. There's my fraction right there, 163 over 200. All right, good luck with the rest.